Okay, welcome back everyone. So today, or a few minutes later, this is the follow-up to the past video, which was just this video. It was the binomial theorem. Just pretend that ever happened. I spelled theorem wrong, so sorry for that. But today we're gonna revisit that in a way and show the relevance of Pascal's triangle in terms of the binomial theorem, because Pascal's triangle is just in general an ingenious mathematical object or mathematical concept. It yields so many mysteries and they're still being discovered today. So I thought I would show you how Pascal's triangle is relevant to the binomial theorem. So let's just write Pascal's triangle. We're not talking about the full Pascal's triangle, we're just relating it to the binomial theorem here. I just don't want to write too much, basically. Okay, so let's get started here. So if you're not familiar with Pascal's triangle, which is surprising, basically this is how the series goes. So you start off with a 1 on the top, and then you think of having two imaginary zeros here, right? So you have 0 plus 1 is equal to 1. So 1 here. 1 plus 0 is equal to 1. Then 1 plus 1 is equal to 2. And that's basically the pattern. Let's go again. We have these, I'm not going to write these imaginary zeros all the time. 1 plus 2 is equal to, or 0 plus 1 is equal to 1. 1 plus 2 is equal to 3. 2 plus 1 is equal to 3 again. 1 plus 0 is equal to 1. And this goes on this goes on infinitely. We can and now I'm actually going to continue this until the second row, and you'll see why. It's going to be really cool. So 0 plus 1 is equal to 1. You can tell there's 1s all the time. And then 1 plus 3 is equal to 4, right? 3 plus 3 is equal to 6. 4, and then as you can see, it just repeats on the side, so you can just do the first few. 5, 10, 10, 5, 1, and then you're going to start seeing the pattern here. 15, 20, 15, 6, 1. It's a little off-centered, but you get the idea. And just make sure, yep. So look at this last row here. Look at it for a moment, and you're going to see something just truly cool, for lack of a better word. So if you look at that, and then you look at ours over here, just pay attention to the coefficients, right? So for our first term here, we have 1 next to the a to the 6th. We have a 6 here. 15, 20, 15, 6, and 1. This is a b. And again, we see 1, we see a 6, we see a 15, 20, 15, 6, and a 1. So obviously, this is going to be a short video, but I just wanted to show you how really cool this was. That Pascal's triangle provides you with the coefficients of the given a given binomial to the nth power. So all you have to do is, for example, if you have a binomial to the power of 20, you do this. You look up the longest Pascal's triangle. Go to the row 20. Then you find your coefficients, and you can completely skip the combinatory step, which is the confusing step, right? And all you have to do is just, basically, the formula just becomes, well, I wouldn't call this a formula anymore, but you just sum k equals 0 to n equals, to 6, or to n, my bad, to n of a to the n minus k times b to the k. So this is all you have to do, and then you have to write, and then all you have to do then is write down the coefficients afterwards on the given row. So if you do row 20 again, you find those, you go to the Pascal's triangle, go to row 20, and you find your coefficients. Anyway, hopefully you enjoyed that very short video, and I'll see you hopefully tomorrow. Hopefully you understand how cool this truly is, because I think mathematics can be very beautiful sometimes. Okay, well, have a nice day. Bye.